Welcome to First Factor. Today we're going to dive into a higher tier GCSE Maths predicted paper. This is paper 1, the non-calculated paper. So I've put this together by analysing trends from previous exams and focus on the questions that I think are most likely to come up. It's your shortcut to smarter prep and exam success. This is just the start, so whether you're aiming for a pass or pushing for the top grades, stick with me and let's make it happen. So before we get started, head over to firstfactor.net to grab a paper. The site's freshly launched, so don't mind the bare bones look. You'll find a link there, download it, give it your best shot, and then come back here. Okay, enough chit chat. Let's jump straight into question 1. Okay, so question 1, we have a fairly easy fraction question here. We simply have two fractions. We need to make sure the denominator is the same for both. So for one, we have a denominator of 5. For the second one, we have a denominator of 10. So clearly, the first fraction, we're going to need to rewrite it so that the denominator is 10. In order to do that, we're going to need to times both numerator and denominator by 2. That's going to give us 4 over 10. Our second fraction is 3 over 10. So we add them together, we're going to get 7 over 10. And that is the answer to our first question. And we have 2 marks now in the bag. So question 2, we've got an algebra question, a pretty easy one. I'm not going to go into too much detail in terms of explaining it. So we have 3x minus 7 equals 14. And solve for x. So our first step is we add 7 to both sides. So we add 7 to both sides. That gives us 3x equals 21. The next step is we divide both sides by 3. So that gives us x on the left hand side. On the right hand side we have 21 divided by 3, and that gives us a value of x, which is 7. That is probably the easiest 3 marks you'll ever get in your life. And let's move on to question 3. So question 3, we have a triangle, it has sides of lengths 5, 12 and 13. So show that the triangle is a right angled triangle. So in order to do this, we need to really think about which formulas do we have in GCSEs that involve right angled triangles, right? So we've got Pythagoras or we have trigonometry. Now in this case, the only thing we're given is 3 lengths. So it's very likely they're not asking us for any angles. So it's very likely it's going to be Pythagoras. So in that case, let's start off by drawing a triangle. So there's a triangle here, right angled triangle. My artwork, as you can see, is not the best. Anyways, we have a triangle here, right? And the hypotenuse is always the longest length in a triangle. So out of our 3 lengths we're given, the hypotenuse will go here, opposite the right angle, that's 13, and the 5 and the 12 doesn't really matter which way around they go. But now we've drawn out a triangle. So how can we prove this is a right angle triangle? We just really need to take these numbers and apply them to Pythagoras' theorem. So we know the formula for Pythagoras' theorem is a squared plus b squared equals c squared. C is always the hypotenuse, so let's call this c, let's call this a, let's call this b. So if we can prove that this works, we've proved this a right angle triangle. So 5 squared plus 12 squared. If this equals 13 squared, we proved this a right angle triangle. So 5 squared is 25, 12 squared is 144, and 13 squared is 169. 25 plus 44 equals 169. We have 169 on both sides. We proved that this is a right angle triangle, and that's 2 marks in the bag. Now, next step, we have to find this area. So in order to find the area of a triangle, it should be, again, very straightforward. Simply base times height divided by 2. Some people might get confused because there's 3 numbers involved here, but our base is 12. Our height is 5. So that gives us 60. Don't forget to divide by 2. And that means that its area is 30 centimeters squared. Now don't forget to put the centimeters squared, because I have seen instances where you simply forget to put that and you'll lose the mark. You have questions like this, right, which when you initially look at them, you think Pythagoras and trigonometry, you always need calculators, but this is an example where you have a Pythagoras question and it's non-calculator. So question 4, we have a recipe which uses a ratio of 3 to 4 for sugar to flour. We're told that we have 120 grams of flour. How much sugar is required? A lot of times people get confused in ratios because they're taking the 120 and they're like, how do I split it across the 3 and the 4? In this case, the 4 parts relates to 120. So we have 7 parts in total. We have 4 parts that relates to 120 grams. So we can use that information to work out how many 3 parts is. So let's take 4 parts is equal to 120 grams. We can work backwards to work out how much 1 part is. So 1 part, if we go from 4 to 1, you have to divide by 4. So we take 120, we divide that by 4. That gives us 30 grams. Now we're interested in sugar. We know sugar is 3 parts. So we're going to work back up to 3. How do we go from 1 to 3? Well, we have to times by 3. So if we times this by 3, that's going to give us 90 grams. And that is our answer for 2 marks. Okay, so question 5, we have another algebra question. It's expanding and simplifying. So we have 2 brackets. We just need to expand it out and then simplify. So how do we do that? Well, firstly, we do the 3x times the 2x. Then we're going to do the 3x times the minus 5. Then we're going to do the 2 times the 2x. And then finally, 2 times the minus 5. So 3x times 2x is 6x squared. 3x times minus 5 is minus 15x. 2 times 2x is 4x. And finally, 2 times minus 5 is minus 10. With these questions, the terms that are the ones that simplify always going to be the 2 middle terms. They're both the ones that have x. So our final answer is going to be 6x squared. Minus 15 plus 4 is minus 11x. And then finally, minus 10 at the end. That's 2 marks. Now, for part B, we've got the exact same. We have the 2 brackets and it's equal to 0. So usually we're given a quadratic. We then have to factorize up to this point. And to solve it, we're at this stage here. But in this case, we're just doing the final step. So one of these brackets has to be equal to 0 in order for when we multiply it together, our answer to be 0. So we're going to have 3x plus 2 equals 0. And then we're going to have 2x minus 5 equals 0. So let's solve both of these, starting with the one on the left. So minus 2 to both sides. 3x equals minus 2. Then we're going to divide by 3. X equals minus 2 over 3. You can leave it as a fraction or as a decimal. Then the one on the right, add 5 to both sides, gives us 2x equals 5. Then divide by 2, gives us x equals 5 over 2. So our 2 solutions are x equals minus 2 over 3 and also x equals 5 over 2. Now, often with these questions, right, you're only going to lose marks when you're getting your pluses or your minuses. You're doing that incorrectly, so you're going to lose marks there. Fundamentally, this is all to do with quadratic equations, and although this isn't a quadratic equation itself, it's really important that you can do those initial steps of factorizing quadratics in order to then get to this step. So let's move on to the next question. So question 6, a lot of people find these type of questions confusing. So we're told the mean of 5 numbers is 12. 4 of the numbers are 10, 14, 15 and 8, and we need to find the 5th number. So with a question like this, we need to work backwards. So how do we work out the mean of a number? Well, we add all our numbers up together. We divide by the amount of numbers that we have. In this case, we have 5 numbers in total, and that gives us our mean, which in this case is 12. So let's just call it x for a second. So x is going to represent all our 5 numbers added together. So our 5 numbers added together are going to total 60, because if we times both sides by 5, that's going to give us our x equals 60. Now we know the x's are 5 numbers added together. So our 5 numbers, if we add them together, remember this is non-calculator, so let's add them up quickly. 10 plus 14 is 24. 24 plus 15 is 39. And then 39 plus 8 is 47. Well, we need x. We know x is equal to 60. So if 4 of our numbers are 47, our final number must simply be 13, because we know our 5 numbers added together are going to give us 60. So we know the 5th number is 13. So moving on to question 7, we have a value of a car. The car is 17,000 and we're told that it's decreased by 15% in a year. Now a lot of people will see a question like this, they'll see 17,000 and they'll think they need to reduce it by 15%. However, the question here is actually asking us to work out the value of the car before the decrease. So it's already been decreased by 15%. So in order to do that, right, we need to work out how much is 100% of the value of the car. So we've already taken 15% away. So we know that 85% is 17,000. So we have 85% is equal to 17,000. And we want to work out the original price before we knocked off 15%. We want to get back to 100%. So this is non-calculated. It's going to be a little bit long-winded. What we're going to do is we're going to work out 1%. So in order to do that, to work out 1%, we're going to need to take 17,000 and we're going to have to divide it by 85. So I'll do that just on the left here. So you can see the steps. So 85 doesn't go into 1, it doesn't go into 7, or 17 rather, but it does go into 170, it goes into 170 twice, and then it doesn't go into 0 and 0. So 1% is equal to 200. So it actually when you looked at this originally, we thought, wow, this is going to be really difficult to answer. We're going to have to do 17,000 divided by 85. It's non-calculator, how I'm going to do it. But you have to remember, it's only question 7. They're not going to make the question too tricky at this point. So 1% is 200. We want 100%, so which means we're going to need to take 200. We're going to have to times it by 100. So 100% is equal to 20,000. And that is the original value of the car for the decrease. And we have 2 marks for that. Now, question B is really the type of question that most people expect. We're going to be taking 10% off the value of the car. So this is now the second year. So the car is worth 17,000. We're going to knock 10% off, which means we're going to take 17,000 and we're going to effectively multiply by 90% or 0.9. Now again, this is non-calculated. There's a few ways you can do this. The way I'm going to do it is by working out 10%. If I can work out 10%, then I can work back to 90%. So 17,000 times by 0.1. 0.1 is the same as 10%, just as a decimal. So that's effectively taking the 17,000 and dividing it by 10. So it's going to give us 1,700. We're then going to take our 1,700 and we're going to times it by 9, which is going to give us the value once we've taken 10% off. So what's 1,700 times by 9? I've got no idea, so I'm going to have to calculate it on the left hand side. So 9 times 0 is 0, 9 times 0 again is 0, 9 times 7 is 63, 9 times 1 is 9, add the 6, give us 15. So the answer is 15,300 once we've taken off 10%. Question 8 looks fairly straightforward. So we've got a fraction, 2 fractions, then we're timesing it by a number. So we just really have to take this in steps. So let's do the first thing, which is let's solve this, and then we can focus on times by 6. So let's do 4 over 3 divided by 2 over 5. So this is really, especially at question 8, this is quite a dream question. How do we divide one fraction by another? Well, we have to turn the divide into a times and flip the second fraction. You should all know how to do this. We have 4 over 3. I'm going to make this multiply, and we're going to flip the second fraction. So 2 over 5 is going to become 5 over 2. So what does that give us? Well, 4 times 5 is 20. 3 times 2 is 6. Simplify that further. We divide both numerator and denominator by 2. That gives us 10 over 3. Okay, so we've done the first part. We've done 4 over 3 divided by 2 over 5. That gives us 10 over 3. Now, we have 10 over 3, and we need to multiply that by 6. A couple of ways you can do this. One way is we know that whenever we've got a number times by a fraction, we're always timesing the number against the numerator. Or we can take our 6 and we can just convert that into a fraction. So 6 as a fraction is just 6 over 1. So that gives us 10 times 6, which is 60. And we have 3 times 1, which is 3. 60 over 3 gives us 20. And that's 2 marks for that. So now we're moving on to the really fun questions. Question 9. This, off the face of it, looks like some sort of probability question. But let's have a read through. So a bag contains 3 red balls and 2 blue balls. A ball is selected at random. They've even put it in bold for us. Really important that ball is not replaced. That's going to be important when it comes to filling in the tree diagram. So a ball is selected at random, not replaced, and then the second ball is collected. Complete the tree diagram below by filling in the missing probabilities. So the key bits of information that we need to understand is that each of our 2 branches in a tree diagram, they need to add up to 1. So that's really important. So we know a bag contains 3 red balls and 2 blue balls. That means we have 5 balls in total. So in our tree diagram from our first pick, that simply means that our probability is 3 over 5. They've given us that one. We have 2 blue balls, so that means our probability of picking a blue ball from the first pick must be 2 over 5. And again, we know that the check is that our 2 probabilities add up to 1. So 3 over 5 plus 2 over 5, that does give us 1. Now for our second pick, this is where it gets a little bit more interesting. We know a ball is not replaced, so we no longer have 5 balls, we now have 4 balls. We have 4 balls to choose from. What's the probability that we pick a red when we've already picked a red from the first one? So from our first pick, we picked a red. That means we no longer have 3 red balls. We now have 2 red balls, and that's our probability is going to be 2 over 4 balls that we have in total. Then doing the branch for blue for the second pick, well, we picked a red. That doesn't affect the amount of blue balls we have. We still have our 2 blue balls. So we're going to put 2 over 4. And again, 2 over 4 plus 2 over 4 gives us 1. Now, if we pick a blue, that means we still have 3 red balls. So our probability here is going to be 3 over 4. If we pick a blue, that means we don't have 2. We now have 1 blue ball. So our probability here is 1 over 4. And again, our check is 3 over 4 plus 1 over 4 gives us 1. Let's move on to part B. So part B, we need to calculate the probability of picking 2 balls of the same colour. So let's have a look at our tree diagram. Which routes can we take which will give us 2 balls of the same colour? Well, that's either going to be this route here, red and red, or it's going to be blue and blue. So hopefully you're familiar enough with the and the or rule in probability. At some point I may do a video on it if anyone needs any particular help. But let's have a look at this. So we're going to take the root of red and red, or we're going to take the root of blue and blue. If we take either of those roots, that means that we'll be able to work out the probability of picking 2 balls of the same colour. So let's have a look here. We've got red and red, and means times, but let me just write this out. So red and red, we're going to put probability of picking a red and a red, or we've got the probability of picking a blue and a blue. Now we know from our probability, we know and is multiply, we know or is plus. So we're going to have red and a red. We know the probabilities here. What's the probabilities? We've got 3 over 5 and we've got 2 over 4. So we're going to have 3 over 5 times by 2 over 4. Or means plus. Then we're going to have blue and blue. So our blue is 2 over 5. And our blue here is 1 over 4. So in times it by 1 over 4. So let's just set about calculating this. So again, it's just really just fractions, and it's really important to remember the order of operations, because we've got to times these together before we can then focus on the addition in the middle. So 3 over 5 times by 2 over 4 times our numerators times our denominators. 3 times 2 is 6. 5 times 4 is 20. We're going to add that to 2 times 5 is, sorry, not 2 times 5, is 2 times 1, which is 2, and 5 times 4, which is 20. Now, we're adding them together in our denominator. As you may remember from question 1, the denominators need to be the same. In this case, they are the same. So that means we can go straight to adding these two fractions together. So 6 plus 2 is 8. So we're going to have 8 over 20. That's our final answer. We can simplify it further. So you literally just divide both numerator and denominator by 4. But in this case, we don't necessarily need to simplify it. We're still going to get the 2 marks. So now we're moving on to the really fun questions. This is my favourite topic in GCSE, quadratic equations. So we're given an equation, y equals x squared minus 4x minus 5. And we're basically told to factorise it for 2 marks. So rather than using the quadratic formula, I like to use the M and the A method. I find it much more easier to understand and much more straightforward to use. Hopefully you're all familiar with it, but if not, again, I can create a video on it. So our M is going to be minus 5 and our A is going to be minus 4. We need to find two numbers that multiply to give minus 5 and add to give minus 4. Those two numbers are minus 5 and positive 1. Because we don't have a number before the x squared, we can literally whack it straight into brackets. So we're going to have two brackets, both starting with x. And we know our two numbers are minus 5 and plus 1. So we're going to get x minus 5 here and x plus 1 here. So that's our first 2 marks in the bag. Moving on to part B. Find the roots of the equation x squared minus 4x minus 5 equals 0. So in order to do this, the first step is factorising. However, we've actually done that from part A. So we can rewrite x squared minus 4x minus 5 equals 0 as x minus 5 and x plus 1 equals 0. This is very similar to one of the earlier questions we had in the paper. So in order for us to multiply two brackets together and the answer to be 0, that means either this bracket or the second bracket need to be equal to 0. So we're going to have x minus 5 is equal to 0, or we've got x plus 1 is equal to 0. So we're going to add 5 to both sides. Gives us x equals 5, and we're going to minus 1 to both sides. Gives us x equals minus 1. So we have x is equal to 5, and we also have x is equal to minus 1. So it's quite an easy follow-on question from part A. Just another thing to add is you'll notice that I do the working out for literally everything, even simple things like this plus 5 here. And that's really because mistakes can come from complacency. And if you stop doing the working out, there's going to come a point during the exam where you start losing the odd mark here and there. And every single mark matters in order to achieve the level that you want, which is hopefully a level 9. So let's move on to part C. Okay, so we need to sketch the graph of the quadratic function. So this one is a little trickier, but let's have a look. So we're going to have to sketch a graph. We're going to need a few things in order to sketch the graph of a quadratic function. One is we're going to need to understand what the roots are. Well, we've done that from part A. So we know the roots are minus 1 and 5. I've just swapped them around so the minus 1 is first because it's a lower number. The next thing we're going to need is the vertex. So the vertex is essentially the turning point of the graph. Now to work out the vertex, let me just do it on the right hand side. For the formula ax squared plus bx plus c, what we do is the formula is minus b over 2a, and that will allow us to have the x coordinate from our vertex. Well, our formula, we know the a is 1 and we know the b is minus 4, so we're going to do x is equal to, as I said, the b is minus 4, so it's a double negative, so it's going to be plus 4 over 2 times 1, which is just 2. So our x coordinate is 2. If our x coordinate is 2 and we pop that back into our original equation, let's just work out what our y coordinate is. I'm just going to do this by speaking it out rather than writing it down. So x is equal to 2. 2 squared is 4. Minus 4 times 2 is minus 8. So we have 4 minus 8, which gives us minus 4. And then we have minus 4 minus 5, which gives us minus 9. So that's our vertex. Now the only other thing we're going to need is the y-intercept. Once we have this, we have enough information to then draw this out. So the y-intercept is really easy. This is basically where does it intercept the y-axis. It's going to intercept the y-axis where x is equal to 0. So if we put 0 into our equation, we can check that from part A that our equation is y equals x squared minus 4x minus 5. So if we put 0 into here, let's just write that out. So we're going to have y equals x squared minus 4x minus 5. So y is equal to 0 squared, which is going to be 0, minus 4 times 0, which is going to be 0, minus 5. So basically y is equal to minus 5. So our y-intercept is going to be 0, minus 5. Let's see if I can find some room to sketch this out. I'm going to sketch this out over here. So let me just draw out a graph. So we've got all the information that we need. We know it's going to be a normal quadratic curve simply because there's not a minus before the x squared. So we have roots. Let's just mark out. We're going to have roots here. Let's call this minus 1. Let's call this 5. It doesn't have to be completely accurate. They've asked for a sketch. They're looking really to make sure that we can plot all our points out correctly. So we have our roots of minus 1 and 5. We have our vertex, which is our turning point. So our turning point is going to be, let's just call it somewhere down here, minus 9. And let's call this 2. So our turning point is going to be about here. And then finally, our y-intercept, that's the point where it intercepts the y-axis. We know 0 is here. And let's put minus 5 about here. Again, like I said, it doesn't have to be exactly accurate. So that's minus 5. So we literally just sketch this out. This is a regular quadratic curve. So forgive my artwork, but it's going to be something like this. So we've sketched this out. And this is really a great question for 5 marks. Question 11. We're told a cylinder has a radius of 5 and a height of 12. Calculate the volume of the cylinder. Give your answer in terms of pi. This is really key here. Again, being a non-calculated paper. They've been quite nice to us. They've actually given us a diagram of the cylinder. We can see that the radius is 5 and the height is 12. And we need to calculate the volume. So how do we go about calculating the volume? Well, we need to work out the area of the cross-section, which is going to be effectively like the lid of the cylinder. We need to work at that area. And then we need to times it by the height. So let's work out the area of the circle on the top. How do we work out the area of a circle? Easy, it's pi r squared. So in this case, pi r squared, we know r is 5. So we're going to have pi times 5 squared. 5 squared is 25. So we're going to have 25 pi. Right, that's effectively the circle on the top. Now to work out the cylinder, right, the volume of the cylinder, we need to times this by 12. So we're going to have 25 pi times 12. Now you should all be able to do this in your head. 25 times 12 is going to be 300. So the volume of the cylinder is equal to 300 pi. That is in terms of pi. Part B, the cylinder is cut horizontally at half its height to form 2 smaller cylinders. Calculate the volume of one of these smaller cylinders in terms of pi. Okay. So we have our cylinder here. They're telling us that we are going to cut this effectively in half its height. So about here, right? So we're not interested in 12 centimeters anymore. We're only interested in 6 centimeters. And again, they just want the volume. And it's only 1 mark, which tells you that it's going to be something which is very straightforward. So we know that the volume for the whole cylinder is 300 pi. So to work out half of it is simply just going to be 300 pi divided by 2. So it's really as easy as that. So 300 pi divided by 2. 300 divided by 2 is 150. So the answer is 150 pi. So question 12, we have a map which has a scale of 1 to 50,000. Part A, on the map a road measures 12 centimeters find its length in kilometers. So there's a couple of things we're going to need to do here in order to secure the marks. First is we need to work out how many centimeters is the actual road. So we know on the map it's 12 centimeters. We're given the conversion, the ratio in order to convert. So we're simply going to do 50,000 times by 12. And that will give us our actual road length. So 50,000 times by 12, in your head, 600,000 centimeters. So a lot of people, they'll put 600,000 centimeters, but where they're going wrong here is they ask us to give the actual length in kilometers. So we just need to convert this to kilometers. So there's a couple of ways you can do it. Either you just know that it's 100,000 centimeters, which is 1 kilometer. Or if you're not unsure, you're in an exam pressure environment, just do it in steps. So first convert centimeters to meters. How do we do that? Well, there's 100 centimeters in a meter. So to convert this into meters, you would just knock off 2 zeros. So that would give you 6,000 meters. And then we know that meters in a kilometer, you have 1,000 meters in a kilometer. So similarly, you knock off 3 zeros, dividing it by 1,000 to work out that there's 6 kilometers. So that's part A, nice, easy. 2 marker, just pay attention to the fact that they want it in kilometers. Now for part B, much trickier question. I'd probably say the first real difficult question in the exam where the majority of students are going to lose the marks here. And it's not bad. I mean, it's coming in question 12. So at this point, I expect the first 10, 11 questions, I expect you to be getting the majority of the marks in the bag. So let's have a look at part B. A park has an actual area of 2 kilometers squared. What will its area be on the map in centimeters squared? So as a quick pause, this is my very first video on first factor, and I'm so excited to have you here on this journey with me. My goal is to help you smash your GCSE maths, and your support can make all the difference. If you're finding this helpful, please give this video a like and hit subscribe. It's a small action, but it will really help the channel grow and keep the content coming. Thanks so much. Let's dive back in. So we're going to need to do a couple of things here. The first is to work out the real area in centimeters squared. They've given it to us in kilometers squared. So to convert 2 kilometers squared, first thing we need to do is we know that 1 kilometer is equal to 100,000 centimeters. In order to work out how much 1 kilometer squared is, we just need to square both these. So 1 squared is just 1. Then 100,000 squared is just going to be adding another 5 zeros on top. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This many centimeters squared. Well, we know it's 2 kilometers squared, so it's really easy. We're just going to be times that by 2. That's going to give us this, whatever number this is. Okay, so that's really the first stage of this. We've worked out that there's this much centimeters squared. I could put the commas in, looks like it's around 20 billion centimeters squared. Next is we need to look at the map scale. So the map scale we know is 1 to 50,000. However, that's in centimeters, but above we've got centimeters squared. So we need to convert this map scale, which is in centimeters, into centimeters squared. So very similarly, we're going to square both of these. So we're effectively going to create, here we've got a length scale factor, and we're going to create an area scale factor. So we're going to square both of these. This is going to give us 1 here. If we square 50,000, we're going to get 2, 5, 1, 2, 3, 4, 1, 2, 3, 4. Right. So we know 2 kilometers squared is 20 billion centimeters squared. And we need to divide this huge number by this number here. Doing that will give us the amount of centimeters squared that our park is. So really easy. Let's do that here. Running out of room, but I'll just put it right at the bottom. So we have 2 think it was 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Dividing it by, let's put it here, 2, 5, 1, 2, 3, 4, 1, 2, 3, 4. So we need to do is this number divided by this. Really easy. Let's just cross out the zeros. So just match them off. Basically until we run out of zeros in either the numerator or the denominator. And then it should be fairly easy then to find our answer. Okay. So we have 200 divided by 25, which means that the answer is 8 centimeters squared. So quite a tough question, as you can see, in order to gain 2 marks. Moving on to question 13. So we have a coffee shop which sells 2 types of drinks, lattes and cappuccinos. On Monday, the shop sold 3 lattes and 4 cappuccinos for a total of £15. Then on Tuesday, the shop sold 2 lattes and 5 cappuccinos for a total of £14. Write down 2 simultaneous equations to represent this situation. So it's pretty easy. As a question 13, we just need to write down the simultaneous equations. So, and that's for 2 marks. We don't even need to solve them at this point. So let's just call lattes X. Let's call cappuccinos Y. So we're going to have 3x, and then we're going to have 4y, and that gives us £15. So we're just going to write 15. And then on the second line, for our second equation, we have 2 lattes, so 2x, and we have 5 cappuccinos, and that gives us 14. And that is our 2 marks. So for part B, we need to solve the equations. Fairly straightforward. Let's call this equation 1, this equation 2. None of our x's or the y's are the same, so what we're going to do is we're going to times equation 1 by 2. We're going to times equation 2 by 3, which will make our x's the same. So let's multiply that out. So the first one, we're going to have 6x plus 8y equals 30. Let's call that equation 3. Then we're going to have, we are going to have 6x 5y times 3, so plus 15y equals 14 times 3, which is 42. We're going to call that equation 4. We are going to subtract equation 3 from equation 4, because that's the better way around to do it, so we don't end up with negatives. 6x minus 6x cancels out. 15y minus 8y is 7y, and 42 minus 30 is 12. Then we divide both sides by 7. Means y equals 12. Let's leave it as 12 over 7. We can't give our final answer as 12 over 7 simply because we're going to need it in pounds and pence, but let's leave it as 12 over 7 for now. Let's sub that into the first equation. We should always do our subs and checks in the original equations 1 and 2. So let's sub our y into equation 1. So sub in 1, we're going to have 3x plus 4, 12 over 7 in brackets equals 15. 3x plus, so 4 times 12, 12, 24, 36, 4 is 48. So we have 48 over 7 equals 15. Now it's getting a little bit tricky, and now we can see why it's a question 13. Initially I thought this is far too easy to be a question 13. However, it's making a bit more sense now because it's involving fractions. So we're going to need to do 15 minus 48 over 7. And I'm just going to write up here because we have a bit more room. So we have 3x equals 15 minus 48 over 7. In order to do this, we're going to need to rewrite 15 as a fraction, which is over 7. So we're going to have to times 15 by 7, and the imaginary denominator of 1, we're going to have to times that by 7 as well. So we have 3x equals 15 times 7 is 105. So we have 105 over 7 minus 48 over 7. So 3x equals 105 minus 48. Well, 100 minus 48 is 52. So add another 5 to that, we're going to get 57. So we have 57 over 7. And then finally we need to divide by 3. Divide this by 3. You should know how to do 57 over 7. But essentially we'll times the 7 by the 3, which is going to give us 21. So we're going to have 57 over 21. So we now have our values of y and we have our values of x. Let's convert this into pounds and pence. So let's do y first. So it's just simple division to convert into pounds and pence. So we're going to do 12 divided by 7. 7 doesn't go into 1. 7 goes into 12 once. Decimal here, decimal there. Remainder from when we tried to divide 12 by 7 was 5, so 7 goes into 50 7 times, it's remainder 1, 7 goes into 10 once. And that's now at 2 decimal places, so the cost is going to be £1.71. Very similar. Let's do 57 over 21. Actually, before we do that, we can simplify 57 over 21 because they're both divisible by 3. So 3 goes into 57 19 times, and 3 goes into 21 7 times. Okay, so let's do 19 divided by 7 here. 7 doesn't go into 1. It goes into 19 twice with a remainder of 5. 7 goes into 50 7 times with a remainder of 1, and 7 goes into 10 once. I'm going to leave it there. So our latte is £1.71 and our cappuccino is £2.71. And that is part B done. Question 14 looks like a powers question, so we need to express 1 over 64 in the form 2 to the power of n. Seems relatively straightforward. Let's focus on, it's 2 to the power of n, so let's focus on the 64. We know this is a key part of it. So we're going to have 1 over, let's rewrite 64 as 2 to the power of something. So just doing it very quickly, 2 cubed is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, so 2 to the power of 6 is 64. They want it 2 to the power of n, so if you know your power rules, you'll know that if we bring this up, right, if we bring 2 to the power of 6 up to the numerator, that'll make our power negative, so we can rewrite it as 2 to the power of minus 6. So that's a nice, relatively easy 2 marks in the bag. Now for part B. Initially, I'm not sure where to get started, but let's just focus on simplifying what we can. So we have 8 to the power of 2/3. So let's take 8 to the power of 2/3. Again, with our power rules, we know we can take this 3 and we can cube root 8. So we can rewrite this as 3 cube root 8 squared, which gives us, well, the cube root of 8 is 2. So we have 2 squared, that gives us 4. So now we have 4 times 4 to the power of minus 1. So there's a couple of ways that we can do this. We can either rewrite 4 as a fraction. So similar to the question above, we can write it as 4 times 1 over 4, which gives us 4 times a quarter, which gives us 1. Or we know there's an invisible 1 here, and we know with our index laws that if we multiply 2 numbers that have the same base, we add their powers. So you do 4 to the power of basically 1 plus minus 1, which is just going to be 4 to the power of 0. And anything to the power of 0 gives us 1. So that's basically another way to do part B. Question 15. So we have a straight line L1, that's got an equation of y equals 3x minus 4. There's another line, L2, that passes through the origin and is perpendicular to L1. So there's a couple of key pieces of information we're told in order to find the equation of L2. So one is that it passes through the origin, and then secondly, it's perpendicular to L1. So remember, the two bits of information we need to work out any equation is we need the gradient and we need the y-intercept. So the y-intercept we can actually get straight away because we know it passes through the origin. If it passes through the origin, that means the y-intercept, our value of c must be equal to 0. So all we need now is the gradient. Now how can we get the gradient? Well, they've told us from the line 1, that's got an equation of y equals 3x minus 4, and we know it's perpendicular. So the key with perpendicular gradients, so if you have two lines that cross each other, right, and they're perpendicular to each other, so we have a line here and we have a line here, the two lines, that perpendicular gradients, if you know the gradient for one line, you simply take the negative reciprocal to find the gradient for the other line. So our gradient for line 1 is our 3. So we have m equals 3 for our line 1. So our m for line 2, the negative reciprocal is minus 1 over 3. So now we have both bits of information that we need. We have our y-intercept and we have our gradient. So we literally just pop that into our y equals mx plus c. We have y equals minus 1/3 x. And because the value of c is just 0, we don't need to write plus 0. So the answer is simply y equals minus 1/3 x. And that's question 15 done. So question 16, the surface area of a sphere is given as 100 pi centimeters squared. Find the radius of the sphere. In order to do that, it's really easy as long as we know what the formula for the area of a sphere is. Now, if you don't know what that formula is and you're going into the exam expecting it to be on a formula sheet, you are not ready to smash the exam. Everything that we do, right, every lesson that I give is getting you into that position that you can really ace the exam. And you need to know these formulas like they're completely off the back of your hand. So we have A equals 4 pi r squared, 100 pi, because the area is 100 pi, equals 4 pi r squared. What's going on here? Well, we've got pi in both sides, so we can divide both sides by pi, cancel these two out. We can then divide by 4 both sides. That gives us 25 equals r squared. Then we just have to make the r by itself by square rooting both sides. That gives us a value of the radius being 5. So that's fairly straightforward, 2 marks. Okay, next question, calculate the volume of the sphere in terms of pi. Use volume equals 4 over 3 pi r cubed. So in this case, they've been very kind to us. They've given us the formula, but I still expect you to know what this is. So we have volume equals 4 over 3 pi r cubed. Now, even if you've got the value of the radius wrong from part A, you'll still get the following marks and be able to do this. So don't worry too much if you got part A wrong. So the volume equals 4 over 3 pi. Now we know r is 5, so we're going to have 5 cubed. So now we've got volume equals 4 over 3 pi, and 5 cubed is 125. So right now this looks a bit strange because we've got 4 over 3 times pi times 125. So I'm going to rewrite it as 125 times 4 over 3 pi. Okay, so we need to do 125 times 4, which gives us 600. Actually, that's incorrect. 125 times 4 gives us 500. 500 over 3 pi. So we could simplify this. However, there's no need. They haven't asked for it to be simplified in terms of writing it as a decimal or anything like that. So let's leave it in this format, which is the cleanest format. So we have 500 over 3 pi. Question 17, rearrange the formula to make x a subject. So what we have here is we have y equals to a fraction, where we have 2x plus 5 as the numerator and 3x minus 4 as the denominator. These questions are fairly straightforward, however a lot of people get stuck because they see x in two different places and they just simply don't know how to solve. But the trick with when you have x in two different places is you need to get the question rearranged into a position where you have just the x's on one side, and then we can factorize. So straight away when this sort of question comes up, straight away I've got an alarm bell which is going off in my head, which is saying factorizing. So let's go about doing that. So just to state again, we're going to get all our terms on one side of the equation to have x, and we're going to bring everything else to the other side of the equation. Okay, so start off by timesing by 3x minus 4, both sides. So we're going to times both sides by 3x minus 4. Again, you'll see me doing the work in for everything, and that's simply because if you don't put the work in, you don't show every single step of working out, you're going to start making mistakes and losing marks along the way. Okay, so we have y 3x minus 4, and then we have 2x plus 5. Let's multiply this out and this out. So we have 3xy minus 4y equals 2x plus 5. I said I want all the terms with x on one side. So we're going to do minus 2x to both sides here. And we're going to do plus 4y to both sides here. So we have 3xy minus 2x equals 5 minus 4y. Now we have x in two places, but we can resolve that simply by factorizing x out. So let's do x leaves you with 3y minus 2 equals 5 minus 4y. Then we just simply need to divide both sides by 3y minus 2, which leaves you with x equals 5 minus 4y over 3y minus 2, and that is a great 4 marks. Okay, so for question 18, we're told shopkeeper mixes two types of nuts. Type A costs £4 per kilogram, type B costs £6 per kilogram. He creates a 15 kilogram mixture costing £5.20 per kilogram. How much of each type of nut did he use? So a lot of people, they find this question confusing. They don't really know where to start. They start experimenting with type A and type B, guessing different amounts and hoping that they're basically going to land on £5.20 per kilogram. But really, you get a question like this and it's ultimately just going to be simultaneous equations. So let's have a look. Can we form any equations? Well, let's define the variables first. So let's call x the quantity of type A, and let's call y the quantity of type B. So we know when we add A to B, that's the total weight, and that's going to create 15 kilograms. So that is our first equation. So we're going to have basically x plus y equals 15. So our quantity of A plus our quantity of y is going to give us 15 kg, or 15 in this case. Now equation 2 is going to be all to do with this cost here. So we know that's £4 per kilogram for type A, and we've got £6 per kilogram for type B. So if we take £4, we multiply it by a quantity for type A, we then take £6, we multiply it by a quantity for type B, that's going to give us the total cost. Now what's the total cost going to be? Again, a lot of people will lose marks because they'll put £5.20 here. But that's not the whole answer. It's £5.20 per kilogram. However, there's 15 kilograms of mixture. So we need to do 15 times £5.20. Now simplifying this further will give us 4x plus 6y equals 15 times £5.20. Now you can do the maths on that, but I can just quickly say that 15 times 5 is 75, 15 times 20p is another £3, so that's going to give us 78. So we have two equations here. We have x plus y equals 15 and we have 4x plus 6y equals 78. I could use the original method for simultaneous equations where I multiply this by 4 to make our x's the same, but I'm going to use a slightly different method. I'm just going to make x or y the subject. So let's make y the subject here by minusing x from both sides. So y equals 15 minus x. And I'm going to substitute that into this y here. So we have 4x plus 6. 15 minus x equals 78. Now if we multiply that out, we're going to get 4x plus 6 times 15 is 90. Minus 6x equals 78. 4x minus 6x is going to simplify to minus 2x. Then we're going to do minus 90 to both sides here. 78 minus 90 is going to give us minus 12. And then we just divide by 2. Or divide by minus 2 rather. X equals 6. So we've already got type A, right? Which is our quantity of type A. We know it's going to be 6 kilograms. And then for type B, we just need to substitute x equals 6 into our formula. So we have x plus y equals 15. So we're just going to say 6 plus y equals 15 minus 6 both sides. That gives y equals 9. So we have 9 kilograms. So basically type A is equal to 6 kilograms and type B is equal to 9 kilograms. Question 19, this is another one of my favorite topic, functions. So we have two functions, function f and function g. We're told for function f, we have f, and then in brackets x equals 2x plus 3. And for the second function, we have x minus 1 over 2. So we need to find the inverse function for g. Really easy. What we're going to do is we're going to replace a gx with a y, just temporarily. So we're going to say y equals x minus 1 over 2. We're then going to swap the y and the x. So it's x equals y minus 1 over 2. We're going to solve this, basically make y the subject. So we're going to times both sides by 2. Gives you 2x equals y minus 1. We're then going to add 1 to both sides. So we have y equals 2x plus 1. And now we're going to replace the y, because remember y was our gx, except in this case we would now have the inverse function. So we're going to have g minus 1 x equals 2x plus 1. So as easy as that. Now if we just look at the next question, so we need to solve fg brackets x equals 7. We need to solve this for x. So we need to really focus on what's going on here. So we're taking x, we're putting that into the function g. What does that give us? Well, that gives us this here. So we already have g in the brackets x equals x minus 1 over 2. Now we need to put that into function f, because remember with functions you need to work backwards through the question. So we need to put this into function f. Now function f is 2x plus 3. So we need to put our answer for here into function f. So let's do that. So we have 2, and then we're going to substitute in the x minus 1 over 2 plus 3. Okay, so we just need to multiply this out. Remember, when you've got a fraction and you're multiplying it by a number, you're always multiplying the numerator. So you're going to do 2 times x minus 1. Let's just expand it out in our head. 2 times x is 2x. 2 times minus 1 is minus 2. So you can have 2x minus 2 over 2 plus 3. And we know all of that. Remember, all of this is equal to 7. So is there anything we can do in terms of simplifying? Well, this 2, this minus 2 and this 2 here actually cancel out because they're all divisible by 2. So we can cancel this out. This becomes a minus 1, and we can cancel this out because that becomes a 1. We can also do minus 3 to both sides. So we're left with x minus 1 equals 4, and then we simply need to add 1 to both sides, and x is equal to 5. Okay, so question 20, another one of my favorite topics, which is circles. What's going on here? So we've got a circle. We have a tangent to the circle, which we can see AEB is a tangent to the circle at E. We've also got points C, D, and E. We can see an isosceles triangle going on because of these two lines here. We're also told angle AEC is equal to X. So let's call this X. What else can we see going on? We can see the line here, and there's a couple of theories I can see straight away. So what the angle we need to find is angle OED, which is this angle here. This is the angle that we need to find. We're given it in terms of X, we're not given any numbers. We need to give reasons for each stage of your working. So before I start writing the reasons out, let's just work out the route to the answer. Straight away I can see alternate segment theorem. So AEC is going to be this angle here, which is also X. I can see an isosceles triangle going on as well, which means we can work out this angle here and this angle here. What else? Well, we can see a line from O to E. So let's draw another line here. This is the trick that's going to catch most people out. But there's two radiuses here, which means we've created another isosceles triangle. This may or may not be useful, but I've added it in for now. Finally, actually it was very useful because that's allowed us to work this angle out here. So angle at the circumference is twice, angle at the center is twice the angle at the circumference, which means this must be 2x. And now I think we have enough information to work out this question. Now, maybe not everything I've done is going to be needed. There's many ways with circle theorems that you can get to the answer, but I think I've got enough information now to work out angle OED. So first thing that we're going to need for the reason for the alternate segment theorem. So we're going to say CDE equals X, alternate segment. I'm just going to put AST. I would always write the full words out to make sure there's no confusion in the exam. Okay, now we know this is an isosceles triangle here, so let's use that information to work out angle CED, right? Because I think that's going to be very useful to us. So CED, well, it's going to be 180 minus X is going to give us the combination of this angle here and this angle here. And we then need to divide that by 2 to work out angle CED. So we're going to have 180 minus X divided by 2 because it's an isosceles triangle. Now that simplifies to 90 minus half X. So I'm just going to write 90 minus a half X. And that, I'm just going to put isosceles triangle. Don't judge me on my spelling. I'm not here to teach English. Okay, so we now have this angle here is 90 minus half X. I'm just going to put it in a different color to make sure there's no confusion. So we basically know angle CED, which is this angle here. We know that's 90 minus half X. Okay, so what else is going on? We need to work out angle OED. So if we just knew CEO, it'd be very easy for us to work this out. Actually, we do know CEO because we can see this is a right angle here because the angle of it where the tangent meets the radius is a right angle. So that means that let's put AEO equal to 90 where tangent meets radius. So you know that's equal to 90. So that means that CEO must be 90 minus X because there's a right angle. So then the final step we need to do We know what CED is, and we know what CEO is. So if we do CDE minus CEO, that's going to leave us with OED. So let's do that. So to work out OED, we need to do CED minus CEO. Now CED is 90 minus half x. Be very careful here with brackets. So it's going to be minus 90 minus x. A lot of people will lose mark because of the brackets and not applying the multiply correctly. So we have 90 minus half x minus 90 plus x. Now the 90 and 90 cancel out. Minus half x plus x gives us positive half x. And that is our answer for OED in terms of x. Question 1. Find the set of possible values of x that satisfy both inequalities. We've got two quadratics here. They're in the form of inequalities, but really we need to get this to a point that we find the roots, and once we know the roots are, it's really easy to work out the set of possible values of x. So let's work out the roots of both. This is just simply quadratic equations. Let's do that here. So we have x squared minus 4x minus 5. Let's make that equal to 0 just for a moment. So ignore the inequality signs, make it equal to 0. M is equal to minus 5. A is equal to minus 4. So we need two numbers that multiply to minus 5, add to minus 4. Those two numbers are going to be minus 5 and plus 1. We can whack those straight into brackets. And our two roots are going to be x is equal to 5 and also x is equal to minus 1. Okay, our next equation, 2x squared minus 3x minus 2, make that equal to 0. Two numbers that multiply to give minus 4, add to give minus 3. Two numbers are going to be minus 4 and plus 1. Slightly different method when we have a number before the x squared. So we're going to say 2x squared minus 4x plus 1x minus 2 equals 0. Put the bracket here, factorize the first half. We have 2x, then brackets x minus 2. And we have plus 1. X minus 2 equals 0. Then finally 2x plus 1 here, x minus 2 here equal to 0. Then we just need to solve both. So we're going to have x is equal to minus half and x is equal to plus 2. So if any of this part of the question was confusing, please let me know in the comments. I can do a video in terms of how to solve quadratics. It's fairly straightforward, but I'd expect at question 1, if you're doing a higher tier paper, you know how to solve quadratics. Okay, this is really the easy part of the question. Now let's move on to the sketch. So we've got our roots for both equations. Now we're at a position where we can sketch the graphs. So we have, just draw a little couple of lines here. Sketch both of the quadratic curves. So the first one has roots of minus 1 and 5. So let's just simply, again, forgive my artwork. We have minus 1 here, and then we have 5. What parts are we interested in? Well, it's everything which is less than or equal to 0. So it's going to be everything below the curve. Oops, let me just highlight this. So everything below the curve. So everything here is what we're interested in. Then for the second one, we're going to have roots of minus half and 2. So let's just go through here and up there. Right. So we're interested in, this is 2, this is minus half, this is everything which is above 0. So this time we're going to highlight this, and we're going to highlight this. So what we're interested in here is the values of x which satisfy both these inequalities, everything between minus 1 and minus half, and also everything which is between 2 and 5. So finally, all we need to do is write these. and write what value of x these lie between. So x lies between -1 and -half. So what we need to be really careful with here is the -1 was part of the equal to. So x is going to be more than or equal to -1. But here we don't have the equal to for this root, for the -half. So we're just going to do a -half is more than x. And similarly for the 2 and the 5, let's put the 2 here. Let's put the 5 here. Let's put the x here. So x is between 2 and 5. However, again, the root for the 5 belongs to the first inequality. So this is going to be a more than or equal to. 5 is more than or equal to x. And then x is simply more than 2. So it's quite a tricky question, especially if you've never done one before, but that's the final answer. That's question 21. Okay, so moving on to the final question, which is surds. We've got what looks like a very complicated surd, and we need to write it into the form a root b plus c root d. So let's just go about simplifying everything, simplify as much as possible. It'll become a lot easier to then see the root to the final answer. So 8 root 50, 8, remember with root 50 when we simplify, always put your root first. So it's going to be 8 root 25 root 2. Then we've got -5, which is going to be root 36 root 2. Then plus 6 root 36 root 3. All of that over root 6. Then we have -3. What square number goes into 96? Well, it's going to be root 16 root 6 over root 3. Okay, simplifying it further, root 25 is 5, so 5 times 8 gives 40 root 2. Root 36 is 6, 6 times -5, so we have -30 root 2. Root 66 is 6, times by 6 gives plus 36 root 3. All of that over root 6. Then we have -3 root 16. Root 16 is 4, so 4 times -3 is -12 root 6 over root 3. Root 40 root 2 minus 30 root 2 simplifies 10 root 2. I'm going to rub that out and put that here just in case we run out of room. So we've got 10 root 2. Okay. What else can we do? We can rationalize the surds times in both numerator and denominator by root 6. And here we can times by root 3. Remember, you have to times everything by root 6. So you're going to have 10 root 12 plus 36 root 18 over 6. Then we're going to have minus 12 root 18 over 3. Normally I'd start simplifying things down, but I want to get us into a point where we can combine all our surds together. Let's actually work to the right hand side now. So we want our denominators to be the same, where we can then minus this fraction from the second fraction. So let's times this fraction here, numerator and denominator, by 2. If we do that, we're going to get 24 on the bottom, so 24 on the top, so as your numerator, and 6 in your denominator. And now we can combine them together. So we can say 10 root 12 plus 36 root 18 minus 24 root 18 over 6 here. Okay, so we can simplify further because we know 36 root 18 minus 24 root 18 is going to be 12 root 18. So we've got 10 root 12 plus 12 root 18 over 6. Now how does this simplify further? Well, we know that root 12 is root 4, root 3. We know that root 18 is root 9, root 3. Sorry, root 9, root 2. All over 6. That simplifies further. Root 4 is 2, so 2 times 10 is 20, root 3. The root 9 is 3. Times that by 12, we get plus 36, root 2. Over 6. We're very near to our final answer now. We can divide everything by 2 to simplify this further. If we divide 20 by 2, we're going to get 10, root 3. If we divide 36 by 2, we're going to get plus 18, root 2, over 3. Nearly at the format where we've got a root b plus c root d. We need to apply the 3 to both the 10 and the 18. So we're going to get 10 over 3, root 3, and 18 divided by 3 is 6. So it's going to be plus 6, root 2. And this is our final answer. So our value of a is 10 over 3. Our value of b is 3. Our value for C is 6 and our value for D is 2. And that is the paper complete. Let's talk grade boundaries. So to get a grade 4, which is a passing grade, you need 15 out of 80. To get the big boy grades 7, 8 or 9, for grade 7 you need 45 out of 80. It's just a little more than 50%. To get a grade 8 you need 58 out of 80, which is 73%. Then to get a grade 9 you need 70 out of 80. 88%. Doesn't leave much margin for error because you can only lose 10 marks. I've also made these grade boundaries a little higher than other ones that you may see online because I think the paper wasn't actually too tricky. So 70 seems fair for getting a level 9. Thanks for watching. I hope you enjoyed the video. If nothing else, you're one step closer to smashing your GCSEs. Now here's the plan. I'll be dropping videos for paper 2 and paper 3 over the next few weeks, so hit subscribe. Turn on notifications, you don't want to miss those. As for the channel, I'm still figuring out where this is going. Right now I'm thinking about a 20 to 30 lesson plan to cover every GCSE maths topic that you'll never need. Basically, the Netflix of maths lessons without the monthly subscription. A bit more about me, I'm a qualified accountant. I used to work as a finance director, so I've crunched numbers professionally. If you're curious about how I got there, or if you just want some career advice, let me know and I'll make some videos about that too. If you have any suggestions, please drop them in the comments as well. Thanks again for watching and I'll see you next time.